Hi, how are you? Chris Young here. Welcome to Physics 101 with this book, S1 International for Physics by Lecky, also known as Lecky and Lecky, or used to be known as Lecky and Lecky, the education publisher from Scotland. So, what did we learn about physics today? Well, today we jumped straight into electricity generation, and electricity generation is something that's always been a bit dear to my heart over the past few years, I have to say. There's something about harnessing nature and getting electricity to run our gadgets, which I've always thought was quite cool. So I've got a few gadgets with me today to show you. For example, this little thing I picked up in Japan probably about 10, 15 years ago. This is a little solar powered battery, and you can see at the end there you've got little different things. You've got where is it, in, out, and what else is there? LED, there we go. Yeah, a switch. You've got a thing here that says bat, and you've got three little LEDs here. So there's a solar cell on the front, there's a battery inside. So the most useful thing I use this for is the torch. So I had this on the dashboard of my car for many years, so it was always charging up with the sun, and I always knew that I had a light available if I had a problem with the car at night. So that's great. You can also check to see how you press the bat button here. It tells you what percentage charge it is, so that's 75%. But it's also very useful to charge your phone, and if you gather devices like this over the years, you have to be careful not to lose any of the little connectors. These things are very important. I have a bag full of phone connectors that came with this, and I had to, let's see, you've got this thing, you plug this in here, this is the output, I believe. And then I've got a micro USB connector here, which connects on the end of this. But then I need to connect it to my iPhone, so I had to order a micro USB to Thunderbolt adapter. Is it Thunderbolt? Is it still called Thunderbolt? I don't know. Is it called Thunderbolt? I don't know what it's called nowadays. So it's the iPhone connector. So I can now use this this charges up in the daytime, and I can plug it into my iPhone and charge the iPhone at night, and then we're good to go. But I got this a while ago. It's not that powerful compared to other power banks. What have we got there? Solar panel, 0.8 watts, output 5.5 volts, 500 milliamps. But it works. I would plug it into my iPhone now and show you, but I'm recording this on my iPhone, so I can't. So I'm really pleased I found all of these connectors in it, and it still works. That's one of my mini gadgets. There's another thing that I got in Japan. I remember watching a disaster movie called Japan Sinks, and like the whole country gets almost obliterated with every natural disaster. So after watching that, I ran out to a shop and got a bunch of survival items just in case Japan sunk while I was on it. This is one thing. This is like if there's an earthquake, you've got this doohickey. It's got a handle on it, so you wind it up and it charges a battery inside, and from that battery you've got LED lights in the front. So there we go, that works. Doesn't work for very long, because the trouble with these things is you never use them. And so the battery dies after a while. It's like goes to, if you don't use a battery for a long time, it goes like to, I don't know what it's called, something like dead discharge or complete discharge. It is unable to be charged again, which is a shame. So that's a rule number 2 of these things. Use them sometimes to charge up the battery so they don't completely die on you. But this had the light, it also had kind of a radio on it for emergencies. So you could, and it's got a siren as well. And it also had a charger. You could charge your mobile phone from this, but again, I've lost the cables, so this is just sadly unusable now. I also have this thing. This is a solar powered radio that I got when I was a teenager. So we're going back like a number of years now. Again, this also has a handle on it, so you wind up the battery like this. But it's got kind of a clockwork mechanism inside. And it's in a transparent case, so you can see how it works. See how it's turning the wheel there? So that's going to run the radio. Let's just see if it works. This battery is... There you go. That's still alive. AM, FM, headphones. It's also got a little solar panel on the front. So I'm really pleased that this still works. So I really like things like that. So anyway, back to today. What did we learn today? Well, we've learned about electricity, how it's generated in Scotland, and how we use energy. We use, well, there's renewable energy and non-renewable energy. So renewable energy sources is your clean energy, your wind power, solar power, turbines, tidal, biomass. These are examples of renewable energy. Non-renewable energy is fossil fuels like oil and gas, and also nuclear. I didn't realize, but apparently there's only a finite amount of uranium in the world. So nuclear power, even though people think it's great because you can get so much energy from it, I personally abhor nuclear power stations. I think it's I don't know. I don't even know if I'm allowed to talk about my own personal beliefs during lessons, but I was in Japan when the whole Great Eastern earthquake happened in March 11th, 2011. We had our young son there, and it was a very stressful time when the earthquake happened and Fukushima meltdown took place, and all of the fear and the conspiracy, the not knowing what was happening, and is the radiation polluting the drinking water, and will it have long-term effects on our young child? Oh, it was horrible. So I give a thumbs down to nuclear. But anyway, we're looking here at particularly hydroelectric energy, and the three ways that hydroelectric energy is used in Scotland. The first way is you've got the dam, blocks off the river, you've got a reservoir there, then the water pressure pushes water down, turns a turbine, and you get energy that way. That's all well and good, but these power stations are quite expensive to build, and you can only build them in specific areas in the country. So that's got pros and cons there. Another good system is having two reservoirs. I think I've seen this at Loch Lomond. There are two lochs. There's one up high and one down below, and there's a power station between them. You can see the pipes there. And at times of low demand, the electricity is taken from the grid and used to pump water up to be stored as a potential gravitational potential energy in the upper loch. And then at times of high demand, they open the gates and the water rushes back down again to provide electricity to the grid, and probably make a bit of a profit as well in that case. So that's good and useful. What's the down point of that again? Oh, you need two reservoirs, yeah. The third way is called flow of the river, I believe. Run of the river, something like that. It's where, like, that's how they used to do it in the old days. You got a river, you got a big wheel, the water just turns the wheel, you get your power that way. All well and good. But the downside of that is it's dependent on the season, and if you walk by rivers, then you see the level fluctuates, so it's not very consistent. But these are all clean sources of electricity, and there's it's interesting to see how politics is connected to energy in Scotland in this situation, because I've been trying to research about Scotland's goals. It says in this book that by 2020 they had wanted to produce 100% of Scotland's electricity using renewables, and I haven't been able to find out if they managed to achieve that yet or not, but they probably did, because they're doing quite well. And Scotland is a great country for renewables, because they have a lot of open landscape, like up in the Highlands and in the borders. They have a lot of less populated areas which are ideal for wind turbines and things like that. Unfortunately, then you have to have the infrastructure for getting the energy from those underpopulated areas to like the central belt and the cities where the people are. So swings and roundabouts. We also looked briefly at wind turbines, and yeah, there are a lot of areas in Scotland with wind farms. Again, pros and cons. The pros are wind. I mean, there's a lot of wind in Scotland. They're not that expensive to build, I don't think, or maintain. But people complain, don't they? They don't like having wind farms on these beautiful Scottish landscapes. They also have been known to decimate bird populations, so that's not good. Offshore wind farms are more expensive to produce, but they provide us with a more steady stream of energy, because wind is more consistent offshore. And so yeah, we know we know where we can get our energy and when. With onshore wind farms, we're very dependent on how windy it is. Also, if it's too windy, it could damage the wind turbine. If it's not windy enough, then obviously the turbines don't move. So you need to be careful, and supply and demand and all that. Interesting fact about hydroelectric power stations: the biggest hydroelectric power station in the world is in China at the Three Gorges Dam, and it produces 22.5 gigawatts of power. So giga, that's how many zeros is that? Mega is 6 zeros, so giga is 9 zeros. That's like a billion. It's 22.5 billion watts, which is 3 times the amount of electricity which is needed for the whole of Scotland. So that's pretty amazing, if you ask me. That's about it, I think. That's all we've covered so far today. Electricity, energy, hydroelectric power stations, and wind farms. And it's a fascinating subject. We have solar panels on our roof. I had some installed when we moved into this house back in 2013, and I think it's 4 megawatts of is the max energy we can get from our solar panels on the roof. But it's great because in the summer we can plug everything in, charge up our batteries during the daytime, and then run things at night for free. We also export energy to the grid, so to Scottish Power. We have a contract with Scottish Power, so they pay us. On average, they say that if your house has solar panels, you use about half and you export half. So you write down how many units you've accumulated. You subtract the previous figure from the 3 months before, and that's your 3 months worth of solar power. And then you half that, and Scottish Power pays you for it, and you get a bit of money to help off with your winter bills. So it's great. Yeah, highly recommended. I know it's expensive, but they pay for themselves. I think ours paid for themselves in about 7 years or 8 years, because you're also your electricity bills are low. You're getting money back, which put your bills even lower, and so solar panels are guaranteed for 20 years. We've had them for 10 years. 10 years, yeah. So halfway. I mean, hopefully they'll last longer than 20 years, but it's one of the best things we ever did. So I highly recommend it. But yeah, I think that's enough. 15 minutes. I've gone a bit mental on energy today, but yeah, it's interesting. I think it's one of the most interesting aspects of physics is energy, and it's very important going forwards, globally, nationally, and personally. So yeah, keep an eye on your energy, folks. But that's all for me. Thanks very much for watching. See you later. Bye.